So I'm Wendy Nilsson. I'm the Acting Deputy Division Director in Information and Intelligence Systems, which is in our Computer and Information Science and Engineering Directorate. So IIS is a central role in SISE, and I'm going to tell you a little bit about it, as well as some funding announcements that we have. So we start out with Henry Kautz. If you're interested in AI, you may know Henry. He's very well known in the area, and then I'm lucky enough to be the deputy. So information and intelligence systems is really this nexus where humans and information and computing meet. So we look at information as knowledge, and then computing is the way we get to intelligence from that information. So we put it all together. So in information and intelligence systems, you will really, the human part is very, very important to us. And we have three clusters that are our core clusters. Our first one is robust intelligence. And in this cluster, there is a focus of robotics. There's human language technology, there's computer vision, AI is here. But AI is often in some of the others, and we can talk about that. Machine learning is there, reasoning and representation, and then our computational neuroscience. So we have a big focus in our area on computational neuroscience. Our information integration and informatics program, on the other hand, is really the life cycle of data. Everything from data management to data mining to informatics to retrieval. All of the parts of a data life cycle are important in our III division. Our final division is our human-centered computing division. And this is really where humans and technology interact and are studied. It's that interaction is studied. So human-computer interaction is a big focus there. Social informatics is a big piece. Assistive technologies, virtual human interaction, and learning technologies. All of that is really an important part of our human-centered computing. And I'm telling you about all these programs, but I also encourage you to talk to our program officers in any one of them. They're all exceedingly nice, and they do want to talk to you about a project before you send one in. So please make sure you do send them questions, send a project summary if you have a project, and talk to them about it. So here's our IIS-led projects, and I'll tell you a little bit more about it in a minute, some of these, but we have these three core areas, and we have a funding announcement that really looks at those three core areas. Plus, we lead in a lot of major cross-cutting areas, and I'll tell you about most of these too, because I think they're really important. But I will tell you a little more about our robust intelligent core, and they're really computational understanding and modeling of intelligence. So you can think about it in natural language technology, you can think about it in computer vision, but they're really looking at a lot of use of the real world data. They're doing it in real time, reasoning approaches to these, and it comes to a lot of different scientific areas. But we really have this computational understanding and modeling of intelligence is the core of all of those, of our RI area. Our information integration and informatics core, again, this is the life cycle of data core. So it really looks at the full transformative potential of data, and then how that data becomes information and knowledge in a digital world. So III has all sorts of areas that they're interested in, and it's high dimensional, high velocity data, heterogeneity and complexity are a big deal, diverse functionalities, geospatial issues are a big thing here, data mining, machine learning, informatics, all sorts of things. But most of the things you're going to find in the data lifecycle will touch in our information integration and informatics core. Our human-centered computing core really is looking at new human-centered computing, which wouldn't surprise you from the title, would it? And I think what's interesting in this thing is we know that we're building more and more technologies, and the goal of this is really, of this technology is really to be able to see the kind of things that we're understand the relationship between humans and their technologies. So not just can we build a VR system, but how do people perceive those VR systems? How do they understand those VR systems? You know, we can make, or an XR system, we can make them better. If we're building design protocols for different technologies, how does it work in the visual and virtual space? And how does it affect society and societal function? So these are, it's a really important area, and it's really about how humans work, live in a world that's redundant with computers and blanketed by networks. So I will say one of the things, I know that you're all involved in the EPSCoR and you're all working through that, but you know, I always want to put up our career. We've had some researchers, outstanding researchers from the EPSCoR community who come for their career award. It's really, if you're ready for a career award, I really encourage you to reach out, talk to a program officer. These are really a 5-year award to give you the space and the time to really get to be able to do the kind of research that will build your career. But we really want to create teacher scholars in this. So it isn't just, can you do some rock star science? It's more than that. It's, can you do rock star science and integrate it into your teaching and into your outreach and into all the things that are important in building up a scientific community. And we want to increase participation in those who are traditionally underrepresented in science and engineering. Remember too, it's NSF wide. So even if you don't want a career through III or through IIS, all of the art directorates and offices in NSF participate. There are over 7,000 career awards are made every year. And this also leads to our PCAS, which is our Presidential Early Career Awards in Science and Engineering. They come out of our career awards. So it's a really important program, and it's really exciting. Our eligibility is on the screen, but you know, it really is faculty that hold a doctoral degree, you know, and they are in a tenure track position or equivalent, and they also have educational responsibilities. So they can't just be research scientists. Not that there's anything wrong with a research scientist, but for the career, it's not what we're looking for, because we want that, we really want that interaction between the education and the science. And you can't have had a career award, and you can only submit to not have had more than 2 proposals reviewed. So on the 3rd try, that's the only tries you get. So here's some of the more points. I mean, I think the thing is that people often forget in it when they think about NSF and the career is the education is a huge part of how we think about it. So we're partnering with communities, we're bringing the excitement to students, using the broader community to gather and analyze data. I mean, there's all sorts of ways, and there's so many exciting ways that people do this in their career. So if you're interested, I really suggest you reach out. If you don't know who to reach out to, you can email me and I'll connect you to someone. IIS also has a range of cross-cutting programs. So I wanted you to see a little bit about this. Our crosscuts are really, they really are addressing important, challenging problems, and they cut across the NSF directorates. So if you're interested in one of these, talk to one of us before you're applying. I will say many of them are based on the idea like Pasteur's quadrant from Don Stokes. You know, we think about all the time Niels Bohr as an example in physics of the kind of work that we do here at NSF, because the application wasn't what Niels Bohr was looking for. He was just interested in fundamental physics. But if you think about it, Louis Pasteur, Louis Pasteur did amazing use-inspired work. He was a microbiologist. He was very interested in how microbiology, how this was happening in biology. But it turned out he also had some issues in his community. So he combined the two and did his fundamental science while solving problems. We aren't looking for work like Steve Jobs. Steve Jobs did excellent technology, but he really used the technology that had already been funded and already been developed by others. And nobody wants to be the lower quadrant. So I'll tell you about my program. This is one led by IIS, and it's the Smart Health Program. We have a name longer than any that ever should be allowed, but multi-agency programs often end up with long names. And our program is looking at, we're using advances in fundamental computing, information sciences, engineering, mathematics and statistics, and behavioral and social sciences to seek, we're really trying to transform the biomedical and public health communities by bringing these sciences in early. And if you're work in these areas at all, you know that they have not been transformed in the same way as other industries because we don't have this communication. It's not the communities working together on a daily basis. And so what we're trying to do is get the technical communities to be working with the biomedical community, but making sure we have the right problems from the biomedical side and really advancing the technology on the other. The AI Institutes is it's a new program that we've got, and it really is an exciting program. And it's really transforming AI research. So we saw at NSF the need, oops, it has NIH at the bottom, it shouldn't, sorry. But we saw the need for sustained investments, long-term sustained investments in AI. So we created in 2020 the AI, or 2019, the first AI Institutes came out. And they really are creating a basis for US innovation in AI, really doing amazing AI research, becoming a nexus. We want our institutes to be nexus in the community. We want it to be a place where everybody can connect around this AI area, and also generate the next generation of researchers and the workforce. So many of these institutes are purely foundational AI questions, but others are use inspired. This round we have one that is, well, last round and we had one from when we did in partnership with USDA, and it's on food and agriculture. We have another one this year on food and agriculture. We also have one on biology this year. So bringing AI, well, I know there's been computational biology for a year, but now really advancing AI around the biology topics. So these are 5-year institutes, and they really are, they also include an ethics perspective. So they really build the science, the community, and the workforce and research community around it. We also have a program that we lead. It's called CRCNS, our Collaborative Research in Computational Neuroscience. This is a really interesting program with it's got amazing partnerships. But our CNS program, it's NSF, it's NIH, but it's also dealing with multiple countries. All of those names up there are the links to scientific agencies in other countries. So what they're trying to do is really computational neuroscience, to improve that science around computational neuroscience. And it really is looking for innovative, collaborative and interdisciplinary research. And so they do it in many ways. There's research proposals for this, there's data sharing proposals. And then there's also this parallel international funding. So it's an absolutely fabulous initiative with a whole lot of different opportunities in it. Another initiative that we lead is called RETL, Research on Emergency Technologies for Teaching and Learning. And actually, I'm not sure whether we lead this or the Education and Human Resources. I think we are just neck and neck, and we just co-lead this in an amazing way. It's one of the few that I think on paper it is in our institute, but it really sits beautifully between education and size. And we're looking there for highly interdisciplinary convergent research that brings together learning scientists at the same time as computer science. So what we're trying to do is advance both at the same time. We're really looking at future-oriented work. You know, we don't want to build the next we don't want to build the app for this or for that. These are really, really exploratory spaces trying to try out very new things. And we have a range of NSF partners on this. And as I said, it's joint between size and education, but also our social behavioral and economics branch and engineering also participate. And they're really looking at learning technologies in a range of contexts. And this one we don't lead, but we invest an awful lot in it. And I thought I would talk to you about it just because if you're interested in the rest, you may be interested in this one. Smart and Connected Communities has a huge IIS component to it. And it really is about long-term investments in research and education in trying to bring communities and our technology together. So I think what I think about when I think about smart and connected communities is we often have the we will build it, they will come model. And this is one it really says we need to talk to them and we need to figure out what they need, and then we can build it because they're already going to be there. So it really is an important initiative, and it really deals with all sorts of really important problems. So it's multidimensional. It has any application area you can imagine. I'm working on one right now that's on health and wellness, but the targets they're focusing on everything from grandparents as parents to sound pollution, to air pollution, to housing equity, all sorts of things. And what the idea is with these is they really bring together the community with the technical work. So I think they're a really interesting program. And if you're interested in the kind of science that not just that drives that science and does grade A science, but also makes a huge difference in the community, I think this is one you'd be interested in. So with that, I'm going to stop, and I'm hoping you have questions and I can answer. So I'm going to make myself available now for any questions that anybody has.
Hello, Dr. Nelson. I'm from Nebraska. I'm a faculty, computer science faculty here in Nebraska. And I just had a question about how to distinguish between a core IAS program versus SCH or smart and connected communities. I mean, does it have to do with the collaborations that I have, or does it have to do with the application? I can do core research with health application, but at the same time, it might fit in SCH. So do you have some, thoughts you can offer there, how to actually choose a bit from these programs? Thank you.
And it's Wendy. So.
Oh, I'm sorry.
Just Wendy's fine. So often a proposal can go to either. It depends. I mean, Smart Health only has one level of funding. So if you want to just do a small project, you're probably better off going to the core. One thing is that the combination, the team is much more important in the collaboratives. So the big interest, so on Smart Health, you need the right team. You really need, if you don't have that team fully put together yet, but you think you're on the right track, you might go to the core and really push on what you're doing from the computing perspective. They have a sense, I mean, I've run many panels in the core that have been informatics around health. So I could see them in either way, but often there's a little smaller projects. They might be earlier. But I also think that, it depends what you want to do too. Smart Health gives you more money, more funds potentially, but it's also competitive. So, I think either one, it just really depends on how you want to pitch your project.
Right. And I mean, I did submit an SCH a few years ago. I haven't done it in the recent times, but one problem that we ran into is that the medical professionals on any small project or a large SCH project, the medical professionals have a larger budget because they're just paid a lot more. and so we decided to go to SCH because we weren't sure, whether NSF, small or medium, would fund that kind of a budget. But I don't know whether we did the right thing. So yeah, I mean that's something that that we did discuss while we were submitting the proposal. But I see what you mean. It's I think a little hard to decide. I mean, I understand that you're saying collaboration, this large collaboration is more important in SCH. That's kind of what I'm getting from what you're saying, right?
So the other thing is, let me see if I can be helpful here, because I actually usually have a slide in my deck that says that basically that basic and applied science are a relay race. So you'll put in a smart health and you're leading, and your health people are there, but they're not driving this. They don't have to write the full proposal. That's not what's happening. But if you're successful and you've got a prototype at the end of you're going to want NIH funding, which then your biomedical people are going to be the lead, and you're going to be along because nothing ever works the way you think it will. And then once you're doing this project, and then NIH will give you significantly more money, and they won't get much from NSF, but they can get a lot as you go to the next stage and the next stage. But then at some point you're going to say, wait, we can't do what we need to do anymore because now there's another fundamental roadblock in our way. And then you come back to NSF and they're going to be your junior partner again, and you're going to lead. And then as it takes off again, they lead, you're behind. Does that make sense? So you don't have to give them,
perfect. Yeah.
You don't have to fund them as if this is 100% joint.
That's right.
But
I understand what you're saying is this is one step in this long series of things, right? Okay. Yeah.
And if you talk to them that way, then they're much more understanding versus, oh, I got to be a part of your project. Well, I need 20% of my time covered.
Right. Right. Okay.
Because they're on soft money, but many of them are willing if they see a path forward, because doing these kind of collaborations is new too. They've never worked with NSF, and you've never worked. If you go to NIH direct, it's hard for you to get funded.
Exactly. Yeah.
So you'll both benefit from the relay race.
Right.
So think of it that way, and I think that makes it a little easier. Then you don't have to.
Right.
It's not like a regular collaboration. It's really turn taking. So.
Right. Thank you so much. Thank you.
Oh, no problem.
Thank you.
Other questions?
So I would like to ask a question first. Wendy, thank you very much for spending time with us. And I'm new to EPSCoR. And I have a practical question. I'm running a T2 project, and we're physicists. So we got some young people into the group. And the purpose of our project is to use data revolution to do more work with IceCube, which is a astroparticle physics project. So one situation right now I'm facing, it's not a crisis, but I can feel we need some kind of attention for the future. So the status right now is we have some young people. And the physics we're doing, most senior people like me, I'm not that senior, but I count myself as senior person. So we were born pre-data era. And those young generation, they are pretty good in data science. Somehow they were born that way, I guess. And to my surprise, some of us didn't vision broader enough for those young people to grow, with their capability. So one thing I'm thinking is to get additional funds so that we can let them explore their talent in data science in this digital world. So my question is, usually we, because we're physicists, so usually for this kind of proposal, we also always send the proposal to mathematics and physics division and show them how wonderful the physics we're doing. But this is a little bit different. And the science is great because we're funded, but we want to emphasize, that those young people explore their talent. Maybe they can do something great by using their talent in the astroparticles physics. So I'm wondering whether your division could be a better place for this kind of proposal. Is that something? Is that a real question, or is it just like a illusion?
So it depends on the problem, and I let me first say, I commend you for seeing this as a problem or as a potential. I think you're really doing well by your junior people that you're acknowledging this and seeing this now, because I think this is really important. You're really looking for a pathway forward for them to let them grow into.
Well, let me make it clear. One thing I didn't mention is, if I don't think about the future, we're fine, okay? With the money, what we're planning to do, that's fine. And we can finish everything on time. We can say goodbye to everybody. But that's not the purpose of this T2 project. So I do think something, down the road.
Right. So yeah. The other thing is, so I'm thinking multiple things. It might be worth talking to somebody in our information integration and informatics program, because some of that might come in there. Having your junior people, but also talk to your physics colleagues, because this is becoming a thing in physics. You're not the only person seeing this data science taking off in the physics world. And so I would talk to some of the program officers that you deal with frequently in physics and say, is there a home for this kind of work in physics now? Because I know we have physicists back and forth to size all the time. They've got lots of shared interest areas and roots. So, but I think you will find that this is something they're aware of. And that these are growing areas of research that, while they're not, they may not be advancing the computing or informatics approach as much, or math or stats, whatever approach they've been taught with, but they are advancing the field. So they may have really good suggestions for that too. So I think there's two ways to think about that. And I would encourage in exploring both. Okay.
Thank you.
Yeah. No, and again, I'm so glad you're thinking about this, because
because I joined this session because this year the collaboration will submit the bigger collaboration, the IceCube collaboration. We're going to submit a U.S. science analysis proposal, and when I look at the solicitations, and it doesn't emphasize the data part, the big data part. So I'm glad we have this P2 project, harnessing the data revolution, but somehow I still see something missing somewhere.
Well, I think these fields are growing, and they're growing in ways people never expected. So yeah. Okay. I know we had a fellow working with us last year who was, he was an astrophysicist, but he was working in our big data group. So because he had so much data science background. Loretta, you have more thoughts for us, I hope?
Yes, and I just wanted to sort of speak to track 2. And if you remember, EPSCoR is a capacity building program. And so when we pick a focus area for track 2, it's because we know that there's a lot of potential down the road for an investment. Not just from the foundation, but also on a national level. So harnessing the data revolution is so important. And so we appreciate the work that you're doing. And so once that capacity is built, you could go to a larger scale. Maybe you're ready to start working on STC, and maybe you have investigators who are some of your junior people who are ready to go for those career awards, and maybe you're preparing to lead your state in a track 1 in the future. Those are 5 years out. you know. And so we see that from that track too, there's so many different directions that you can go. And hopefully that provided some, we call it seed funding, some seed funding in 4 years to really build expertise across jurisdictions, you know, for a number of people. And you have the work in size, but you also have work that's in OAC, and there's so many other places, because you probably, I don't recall your project off the top of my head, but you probably applied it to a disciplinary area. So within that disciplinary area, there are probably options. And so, you know, you can talk to myself or JD, or we could get together, and I don't know who your cognizant PO is, and we could really brainstorm as to where can you go now that you've built this capacity. What are some of the options within NSF? And we don't know as much about, but when you think about the other agencies, and that's the purpose of the EPSCoR Interagency Coordinating Committee sessions that we have later in the week, so you can take your work in so many different directions. And you know, we'd love to sit with you and think and help you to explore where all you could go with your work.
Yeah. Okay, I will keep that in mind. It sounds like maybe in the physics and the mathematics and the physics division in the future, they may have some funds to invest on this kind of new data techniques application in their field.
Right.
Is that something people expect in NSF?
Yeah, well, innovation. It sounds like you're driving innovation.
Innovation, and we want to see sustainability.
Yep.
Yeah.
Sabrata, I see your hand up.
Yeah, I just wanted to say that me and Guy talk a lot. So he's always inquisitive, and his project is doing great. And I think he's on the right track. So me, JD, and Guy, we can sit down and then talk about where you could, lead your workforce. You know.
Yeah, that's great. That's great.
Yep.
We should find a time maybe after I submit this first year annual report.
Good idea.
Yes, and also there's an office hour on Friday. If you want to bring in some of those junior folks, junior faculty into our office hours on Friday, 2 to 4. JD will be there. I'll be there. We can talk.
Okay, I will let them know. And these days, people are busy because we're working on multiple proposals, this collaboration. So so far, I'm the only one. I believe I'm the only one joining this meeting. Thank you.
Thank you.
And Wendy, I did have something else I wanted to get your thoughts on. So it's not specific to a funding opportunity, but
okay.
I know that NSF hosted recently like a forum on the PBS documentary on coded bias. Mm-hmm. And so being an AI person myself, you know, I enjoyed that, but it really made me think a lot about when we use these huge data sets for AI purposes, how do we address bias that might have been inherently coded within all of the data that we're collecting, that we're using to make critical decisions. So I would love your opinion on that.
So we're not doing enough, you know that. I think we're moving to that. So like SISE has an initiative called Fairness in AI, mm-hmm. and it specifically targets that problem. And a lot of it is, you know, how do you identify the bias? I mean, even when your data is maybe not as biased, we may not be going for the right outcomes either, right? We might pick an outcome that isn't the right one and ends up with a bias there too. So it's even looking at it from what the stakeholders want. And then how do you also start to really understand what the biases are in the data, and how do you create algorithms that can identify and understand that? But I think I would love to see much more happening in this. We're seeing it coming all over the place. I think there's a generation that is very cognizant of these issues. You know, I think we were also grateful just to be able to have all this data. But I think the next generation especially is now saying, wait a minute, that's not enough. You know, those of us that started early, it may have seemed, it was so good for a while, but now we can figure out what's wrong. And, you know, and I think that that's something I think that size is really interested. I know my division IAS, that's something we care about deeply, because this is where the humans and AI, this is where they should be meeting all the time. So, but we need more. This is just a huge, I mean, I don't even think we understand the depth of what we've got.
Right.
That movie was a great example. I remember when, it came out, what was it? It wasn't that many years ago that we found out, that if you put a kitchen, you ask for kitchen in a search, the computer vision will give you a woman in a kitchen, right? Nobody knew that until all of a sudden, I think probably some women noticed. Kitchen always have women in it. So
the kitchen. I didn't say woman in kitchen.
Right. I didn't say woman in kitchen, but when I get a kitchen, there's a woman in it. Wow, look at that. Look at the bias in that. I feel like that was like, I remember when that one came out and everybody's like, oh. And now I think that was just the tip of the iceberg from where we can be. So I think we need more and more and more.
Great.
This is important. I mean, if we don't even know what you don't know, we've got a long way to go to figure this out.
Yes, because we're not even, most people aren't able to recognize their own implicit biases.
Right.
And so, it could be creeping into the software we write or decisions that we make in hiring in so many ways. And so a first step is just having a fuller understanding of implicit bias. And those are the ones that you're not even aware. I mean, there's some explicit biases as well, but being aware of those implicit biases and then thinking about how they creep into, especially these massive data sets that we're using for major decisions.
Right.
Thank you for your notes.
Yeah, so thank you.
Yeah. So
sorry, I was trying to remember how to pronounce your name. Okay.
No, that's okay. That's okay. Thank you so much. Yep. So that's a great point that Loretta was making and Wendy, you were making. So, one and that triggered this thought in my mind. So I'm actually on a T2 project. I'm one of the co-PIs, and I the PI happens to be at the South Dakota mines actually. So the trouble that we are having in this project is to actually generate the label data that's needed for data mining, and cleaning of the data. So this entire year we were spending on just collecting the data and then cleaning it and then so on and so forth. And but I do recognize that's a very important problem in many fields right now. There are all these tools and there are some fields where there is just too much data available and we are trying to figure out how to work with that. And then there are fields like biofilm engineering where there is data, but it's not labeled, it's not in the right format, and it's all over the place. And then the data sets are small. So people may think they don't need the big data techniques, but you may have to, just because you have to have some scaling up of the available data so that you can statistically, you have statistical correlations. So that's one thing that I am seeing. There are, because of this, there are new fields where there is not enough data even, because people don't think about it. They may repeat the same experiment. Each experiment takes a year for them to finish, and then in this year they don't think about keeping every part of the data because the scientists are busy just using the lab equipment to just finish the experiment. Whereas a data scientist like me comes in and then I say, no, we need that and this, and they have to go back 6 months, and so I know that it's not a research problem, but it is an engineering problem, and any thoughts on how to sort of elevate that problem within NSF or other ways? If you have any thoughts about that, that's I could use those. Thank you.
Yeah, I think, there, in terms of labeling data, I think there's people trying to figure out, can you automatically label? I know in the smart health world, people have been often using retinal data for this. because it appears there is just oodles, whatever reason, there are oodles of retina data. Not sure why, but it is. So they've been trying to figure out, can you automatically annotate, add metadata, do all sorts of things to that data. So I think there are scientific advances to be made, but I think then there are also, I mean, one of the things you're talking about too is a teaming problem, right? If you have to get to, I mean, we've been thinking about this because, like, you know, we actually, our last PI meeting for Smart Health, we had, my FDA colleagues were talking about, you know, some of these projects go for years, and then and they say, oh, well, what happens if we commercialize? And FDA says, well, you have to start over in your data collection because you didn't answer X, Y, Z. So it's sort of the same, it's another continuation of the problem. So I think it's starting these teams as early as possible. And again, that handoff back and forth, because you can't babysit a team forever. You need to build your team and you do it, and then it's cohesive enough that somebody else can take charge and that you can focus on the other things that are important. So that's not an easy answer, and I'm sure it's not satisfying, but I think that I love the fact that you're thinking about these things, because I think that's how we solve it.
Yeah, I think we are going to spend a lot of time thinking about this, because we have lots of data. I mean, we have great techniques. We are developing techniques all the time, but then we need enough data to apply the techniques to. And then we are thinking about semi-automated or active learning of labels and stuff like that. Those are some things that we are looking into. But yeah, thank you. Yeah.
All right, thank you. Well, I think, are we ending at 3:45? Is that what we were ending at?
I think yes, to give people a few minutes.
Between
But
sessions? Yep.
if you have, you know, more to share, we're here.
Okay. If you have more questions, I can answer them. Otherwise, you can always email me. Wendy Nelson at NSF is easy. I am the only one. So, and I'll answer your email. So, and help in any way I can. So thank you so much for being here and for the interesting questions. And I look forward to talking to you more about these things.
Wendy, thank you so much for
Thank you very much, Wendy.
All right.
Thank you very much, Wendy. Thank you.
All right. Take care.
Bye.
Bye.
Bye. And thanks, Beverly, and thanks, Rich.